This is question number 19. Use Stokes' theorem to calculate the flux of the curl of F across the surface S away from origin direction. So what we have is a force function, and then we have a surface, and if you notice, the surface is a sphere. That's a parameterization of a sphere. And if you look at the boundaries, the boundary is from phi goes from 0 to pi half. So this is your z-axis, this is your y-axis. This is where rho is at phi equal to 0, and this is when rho is phi is equal at pi half. So rho goes from angle 0 to pi half. So that's why you have the hemisphere. This hemisphere has a radius of rho, and rho here is 3. So this is your x component, this is your y component, this is your z component. If you square each component, you get 3 squared is 9, sine a square of phi cosine a square of theta. If you square the y component, you get 9 sine a square of phi sine a square of theta. And if you square the last component, you get 9 cosine a square. So if I add these two by factoring the sine a square of phi, I get cosine a square theta plus sine a square of theta. That's equal to 1. So I get 9 sine a square of phi plus 9 cosine square of phi, which is equal to 9. Because again, if you factor the 9, you get sine a squared plus cosine a squared. That's 1, you get 9. So that's why that is the equation of a sphere. And with the boundary, we have a hemisphere. So, having said that, we are going to write the surface as x squared plus y squared plus z squared is equal to 9. I can also write this as a function h, x, y, z that is equal to x to the power 2, y to the power 2, z to the power 2 minus 9. Also, since we have only the top of hemisphere, if I subtract x squared and y squared from both sides, I get z squared is 9 minus x squared minus y squared, square root both sides. Since we have the top hemisphere, then we have z equals to square root of 9 minus x squared minus y squared, which is an explicit form of the surface. So I have the parameterized form. This is the parameterized form. I have the function form, and then I have the explicit form. So I'm going to use all of them. So what does Stokes' theorem says? It says there is a relationship between a line integral over the boundary of the surface and a surface integral over the surface itself. If I want to use the curl says that either you can just go over the boundary of the surface C, or you can just go over the surface S is equal to find curl of F. That's how you find the curl of F. Then take its dot product by N. So we have to find N. And then we have to find D of S. So we are going to use this one to evaluate or rather to calculate the flux of the curl of F across the surface S. So first I'm going to find the cross product of the del operator and F. We have I, J, K, partial with respect to X, partial with respect to Y, partial with respect to Z. And then we have 5Y, 5 minus 3X, Z squared minus 2. A fast way of doing this is we are going to, for I component, to find the value of this cross product. For I component, we are going to look at the J and K column, and we go this diagonal first. We find a partial of Z squared minus 2 with respect to Y, which is 0. Then you put a minus sign. Then you go this diagonal, you find a partial of 5 minus 3x with respect to Z, which is also 0. So that's 0I. So that's why we get 0 here. We get 0I. Then I'm going to find the J component. To find the J component, we are going to look at these two columns. So we go this way first. We find the partial of 5y with respect to z, which is 0. Then you put a minus sign, then go this way. Partial of z squared minus 2 with respect to x, which is also 0. So that's why we get 0j. Then we are going to find the k component. To find the k component, we look at these two. And for this one, again, we go this way first. Partial of 5 minus 3x with respect to x is negative 3 minus, then you go this way. Partial of 5y with respect to y is 5. So we get negative 8k. So we get 0, 0, negative 8. Next, we are going to find n. And to find n, we are going to look at the del of h over the magnitude of del of h, and del of h is equal to 2x I plus 2y j plus 2zk. And then we want the magnitude, which is just going to be 4x to the power 2 plus 4y to the power 2 plus 4z to the power 2. I just want to go over the algebra here. If I have this, I can factor the 4 out. And also we know that x squared plus y squared plus z squared is 9. So I can just replace that and write it as 4 times 9. So for square root of 4 is 2, square root of 9 is 3, so we get 2 times 3. I'm going to leave it as 2 times 3 rather than 6. So I have 2x. I'm going to use this format now, over 2 times 3, comma. For this one, I have 2y over the denominator, which is 2 times 3. 2z, 2 times 3. 2's are gone. So that's what I have. Since they all have the same denominator, 1/3, I can also write n as, keep the 1/3 magnitude outside, and write it as x, y, and z. I need to take the cross product of these two. The dot product. So I have 0, 0, -8, 1/3 x, or you can just write it as x over 3, doesn't matter, y over 3, z over 3, 0 times x over 3, 0, 0 times y over 3, 0, -8 times z over 3 is -8 z over 3. Also, I need to find ds. To find ds, if we have the explicit form, it would be easier to use this formula. You write it as 1 plus the partial of z with respect to x to the power 2 plus z with respect to y to the power 2 dA. So that's how I'm going to find my ds, because I am able to write my surface as an inexplicit form. So now we are going to find partial of z with respect to x, which is going to be, we know z is equal to 9 minus x squared minus y squared to the power 1/2. I got rid of the radical and I wrote it as 1/2. To find the partial with respect to x, we are going to multiply 1/2 by the parentheses. We are doing chain rule. Then subtract 1 from the exponent. So 1/2 minus 1 is going to be minus 1/2. I write 1 as 2 over 2. So 1/2 minus 2 over 2 is minus 1/2 times derivative of inside, which is negative 2x. Derivative of 9 is 0. Derivative of negative y squared with respect to x is 0. Derivative of negative x squared is negative 2x. So then partial of z with respect to x is minus 2x is on the top. 2 is in the denominator, and since I have a negative 1/2 exponent, this factor goes into the bottom. Like that, right? It's positive 1/2, and positive 1/2 means you have a square. We can cancel these 2's, and now we just want to square this. So we get x to the power 2, and then when I square radical, I get rid of the radical. Then we have to find the partial with respect to y. So again, I have to do the chain rule one more time. So we are going to multiply 1/2 by 1, subtract 1 from 1/2 to get negative 1/2 times derivative of inside with respect to y. This is 0, this will be 0, I get negative 2y. So when I clean this up again, negative 2y is on the top, 2 is in the bottom. This will go into the bottom, becomes positive 1/2, and positive 1/2 means we have a radical. And then when I square this, I get y squared over that. So let me write what I have. 1 plus x to the power 2, 9 minus x squared minus y squared, 9 minus x squared minus y squared. I can write 1 as this denominator over itself, because I want to find a common denominator and add the fractions. That's my 1. And then I have the other 2 terms. Now that they have the same denominator, I'm allowed to add the tops. The top is 9 minus x squared minus y squared plus x squared plus y squared. So they cancel each other. So I just get, they all have a dA here. So I have a square root of 9 over 9 minus x squared minus y squared. But then I can also write this as a square root of 9 and a square root of 9 minus x squared minus y squared. But a square root of 9 is 3. And a square root of 9 minus x squared minus y squared is really z. That's what z is. So I'm just going to change it to z. So I have that. So I need this, and then I need the product, this. Those are the two things we have, and we have our integral now. Our integral was curl of f dot n ds over s. So I write what I have. I have negative 8z over 3 times, let me just put parentheses so it's not a dot product, 3 over z, and this is a dA over the region now, R now. So what is dA? dA is the floor, x and y, which is just a circle with a radius of 3. So then I have this, and then I have this one. If I want to go to this region, then I need y is negative a square root of 9 minus x to the power 2, and y is equal to 9 minus x to the power 2, and the boundary for x is negative 3 to positive 3. But again, these are going to be simplified. I get negative 8 dA. But what is dA? dA is going to be dy dx, and y is going from negative square root of 9 minus x squared to positive square root of 9 minus x to the power 2. And x is going from negative 3 to positive 3. But again, I can write this as in a polar form. And the polar form, r is going to go from 0 to 3, and theta is going to go 0 to 2 pi. And dy dx becomes r dr d theta. However, since negative 8 is a constant, I can keep it outside. Whatever method I use, polar or rectangular, this is just going to give me the area of the circle. The area of the circle is pi r squared, which is pi 3 squared. So I get 9 times that is negative 72 pi. And that is our answer.